The mass MT remaining after T years from a 22-gram sample of radium-226 is given by the formula M per T equals 22 e to the minus 0.00043 per time. These are our questions of the project.
The problem is to find the mass m times t remaining after t, a certain number of years, from a 22-gram sample of a radium 226. That is given by m times t equals 22e to the negative 0.0043 times t. First, we have to find the half-life of the radium 226, then graph a model from the equation given, leaving t as a variable. Then graph a new model with the same equation but with a rate of decay of 0.1%. And finally, answer which of the two graphs decays faster and why.
The result of the mass in 1,000 years is 14.31. The result of the mass in 2,000 years is 9.31 grams. The result of the mass in 4,000 years is 3.94 grams of the mass of the initial mass.
This is the graph for the given formula. This is the graph for the percent decay. Exponential growth is the development at an increasingly rapid rate in proportion to the growing total number or size. A constant rate of growth applied to a continuously growing base over a period of time, y equals a times b to the x, only when a is bigger than 0 and b is greater than 1.
The basic model is fx equals e to the x, or y equals a per 1 plus r to the x. The variables are a, r, and x. A, initial amount before the measuring, growth, decay. R equals growth and decay rate, often a percent. X equals number of the intervals that have passed.
The compound interest formula is A equals P plus Rn NT. This formula is used to know the interest added to the principal sum. A equal to the sum of the investment and the interests. P equals the first order principal deposit. R equals the annual interest rate given in decimals. N is for the numbers of times that interest is compounded per year. Finally, T stands for the number of years.
The radioactive half-life for a given radioisotope is a measure of the tendency of the nucleus to decay or disintegrate, and as such is based purely upon the probability. Half-life is the time required to halve the nuclei in a sample of a specific isotope to undergo radioactive decay. FB equals P per 1 plus R over N to the Y per N. FB stands for future value, P stands for starting principal, Y stands for years, N stands for number of times per year, and R annual interest rate. Also write in decimals.
FV equals PE to the power of Y times R. FV equals future value. P equals starting principal. Y equals the years. N equals number of times per year. And R equals the annual interest rate in decimals.